I'm Professor in Mathematics, Center for Distance Education, Shivaji University, Kolhapur. Today I will discuss Lagrangian formulations and in Lagrangian formulation from classical mechanics, MSc part post semester first. Examples on conservation of energy. Take example. Find the velocity dependent potential and hence the Lagrangian for a particle of charge q moving in an electromagnetic field. Consider a charged particle of charge q moving with velocity v in an electric field E bar and magnetic field B bar. The force acting on the particle is called Lorentz force and is given by F bar is equal to Q into E bar plus V bar cross B bar, where E bar and B bar are satisfy the Maxwell's field equations. Del dot B bar is equal to 0 and del cross product E bar is equal to minus dou B bar by dou T. We know that the vector quantity del dot del cross A bar is equal to 0. Thus the Maxwell equation implies that there exists the magnetic vector potential A bar, which is a function of coordinate and velocity such that B bar is equal to del cross product A bar. Substituting in this, therefore del cross A bar is equal to plus the dou by dou T of del cross A bar is equal to 0. Del cross E bar minus plus del cross minus cross dou E bar dou T is equal to 0. Therefore del cross E bar plus dou E bar by dou T is equal to 0. We also know the vector quantity del cross del phi is equal to 0, and we get E bar plus dou A bar by dou T is equal to minus del phi, and E bar is equal to minus del phi minus dou A bar by dou T. Therefore F bar is equal to Q minus del phi minus dou A bar by dou T plus V bar cross del cross A bar, where we have del phi is equal to I dou phi by dou x plus j dou phi by dou y plus k dou phi by dou z. Dou A bar by dou T is equal to I dou A by dou x by dou T plus j dou A y by dou T plus k dou A z by dou T, and del cross A bar is equal to I j k dou by dou x dou by dou y dou by dou z, ax ay az, and we get v bar cross A bar del cross A bar is equal to, and this x component of the Lorentz fold equation becomes fx is equal to q minus dou phi by dou x minus dou A by dou x by dou T plus Vy dou A y by dou x minus dou A z by dou y minus Vz dou A z by dou x minus dou A z by dou x, and we get, and this is equal to dou by dou x of V bar dot A bar is equal to dou by dou x Vx ax plus Vy ay plus Vz az. Therefore dou by dou x of V bar dot A bar is equal to Vx dou A bar x by dou x plus Vy dou y by dou A y by dou x plus Vz dou Az by dou x, and substituting in this, and we get fx is equal to, and this is fx is equal to minus dou u by dou x minus d by dt of dou u by dou x dot for x is equal to Vx, and hence the Lagrangian equation of motion is given by d by dt of del by t by del by x dot minus dou t by dou x is equal to fx, and we get d by dt of dou L by dou x dot minus dou L by dou x is equal to 0, where the Lagrangian is given by L is equal to t minus u, becomes L is equal to 1 by 2 mx dot square plus y dot square minus plus z dot square minus q pi plus q v bar dot a bar. This is Lagrangian. Show that the Lagrange equations of motion d by dt of dou t by dou qj dot minus dou t by dou qj is equal to 0 can also be written in the form dou t dot by dou t dot by dou qj dot minus 2 dou t by dou qj is equal to qj. The kinetic energy T is in general a function of generalized coordinate, generalized velocities and time. Then we have T is equal to T of qj dot T, differentiating this with respect to T. Therefore dt dot by dt is equal to T dot is equal to summation of dou T by dou qk dot plus dou qt by dou qk dot qk double dot plus dou t by dou t, and differentiating this we get dou t dot by dou qj dot, and this equal to dou t dot by dou qj dot minus d by dt of dou t by dou qj dot is equal to dou t by dou qj, but it is given that d by dt of dou t by dou qj dot minus plus is equal to dou t by dou qj plus qj, and consequently equation 5 becomes dou t dot by dou qj dot minus dou t by dou qj plus qj is equal to dou t by dou qj, and we get dou t dot by dou qj dot minus 2 dou t by dou qj is equal to qj. This is next example. A particle of mass m moves on a plane in the field of force given by F is equal to minus ir cap kr cos theta, where k is constant and ir cap is the radial unit vector. Show that the angular momentum of the particle about the origin is conserved, and obtain the differential equation of orbit of the particle. Suppose that x, y and r theta with the Cartesian and polar coordinates of the point of mass m moving on a plane under the action of a given field of force if is equal to minus ir cap kr cos theta. Since the force is explicitly, therefore the Lagrangian equations of motion correspond to the generalized coordinate r and theta are given by d by dt of del by t by del by q theta dot minus del by t by del by theta is equal to q theta, and d by dt of del by t by del by r dot minus del by t by del by r is equal to qr, where T is the kinetic energy of the particle and G is given by T is equal to 1 by 2 m x dot square plus y dot square is equal to 1 by 2 m r dot square plus r square theta dot square. The components of generalized force along the radial direction and in the direction of theta are given by qr is equal to minus ir cap kr cos theta, q theta is equal to 0. Hence the equation 1 and 2 becomes d by dt of mr square theta dot is equal to 0, mr square theta dot is equal to constant. Therefore mr double dot minus mr theta dot square plus kr cos theta is equal to 0. This is the kinetic equation of motion of the orbit of the particle, and it's complete.